In the last lab, we used a Hot Wheels car loaded with pennies, and we accelerated it down a track and then measured its acceleration along the track as well as the angle that the track was at. And from that, we were able to show that the acceleration along the track was equal to g, the acceleration of gravity, times the sine of this angle. Now, we know from Newton's first law that in order for an object to accelerate, there must be a net force acting on that object, because if it wasn't, then it would either be stationary or moving with a constant velocity, which it wasn't in this case. So we know that there must be some force, some net force, acting on the object to accelerate it down the track. And that force is its weight, or rather a component of it. So we know that the weight of this car is pointing straight down towards the center of Earth. But obviously that's not the direction this was moving. It was moving along the track. But if we rotate our coordinate axes so that we have the x-axis pointing down in the direction of the track and then the y-axis pointing up perpendicular to the track, then there would be a component of the weight in the direction of the track. And this is the force that accelerates our car. According to Newton's second law, we know that force equals mass times acceleration. So the force, F, that accelerates an object in some direction is going to be equal to the object's mass times the acceleration that it experiences. So we've already measured now the acceleration. We did that last time, and we measured the object's mass. Now the force that we measured last time was actually the force needed to prevent the object from accelerating. But if we put the object on here, if we put our car on here, connect it to the spring balance, we know that the component of the object's weight is pointing down the track, and then the spring balance force is pointing back up the track. And because the object is not accelerating, those forces must be balanced, or they must be equal to each other. So even though we measured the force necessary to prevent acceleration, in a way we're indirectly measuring the same force that is used to accelerate the object, because the spring balance force is equal to the weight, or the component of weight, in the direction of the track. So from that, we have everything that we need to verify Newton's second law. We have the force that would accelerate the object, we have the object's mass, and we have the acceleration that it experienced. So we have a series of those measurements. We've got several forces, we've got several accelerations, and so if we were to plot force versus acceleration, we should see that the slope would be equal to the mass of our object, which if it is, then it verifies Newton's second law. So there's no actual data collection this time. You're just going to use the data that you collected last time, so you'll have the force, the acceleration, and the mass of the car. But from that, you'll be able to complete your analysis and test and verify Newton's second law. So just read through your instructions carefully, follow that, and good luck on your experiment.